Welcome to this session on refining the model with list functions. In the previous session, we used the width variable to define the width of the mass of the building, and we use that same width at every floor. But what if you wanted to vary the width at different floors? For instance, maybe the lobby floor needs to be a little wider to form the base of the building, or you want to step several floors back at the top of the building in order to form a few penthouse floors. All of these options could be done using the same width variable within an algebraic expression. So let's start by assuming the width variable represents the width of the typical guest room floor. So we're going to start by modifying the form that makes up the lobby floor. So I'm going to go to the form lobby node, and I'm going to select the width input. Go ahead and open the script editor, and I'm going to add 5 feet. So I just need to add +5 to the width. I'm going to apply that, and you can see now the base of the building is 5 feet wider than the rest of the mass. So that was simple enough because the form lobby node only controls that one element. But if we look at the guest room floors, again we have one node, form guest room, that controls all 5 of those floors. And that's because that form guest room node is using the curve input of arc_gr, arc guest room, and that arc is a list because we copied our base arc to all of the guest room floors. So when we have a list as an input, it uses the entire list, all the child members of that list. However, we can use what's called indexing to define individual members of that list, or to identify a child node within that group. So you can affect certain members of a list by calling out their index, and square brackets are used to designate the index or position of an element within its list. So the first position in a list is always 0, the second position is 1, third is 2, and so forth. So if we wanted to change the curve input here so that it was only the first 3 members of that list, I'm again going to open the script editor, we could start by putting a square bracket after the arc_gr input. I'll put 0 in there, that'll be the first member, and then I'm essentially creating a list here of the members of that list that I want. So again, I would put in arc_gr, square bracket, and this time we'll use 1 for the next member of the list, and then arc_gr, square bracket 2. And that'll be the first 3 members of that list. Now again, because I'm again creating a list, I'm going to put that within curly brackets. And then I'll select apply. And you can see now we only use the first 3 arcs to create forms, and I have 2 arcs left over. So in that way, I've controlled which members of the list to include in that node. Now I'm going to right-click on that node and select copy, and then paste another form node on the graph. I'm going to call this one form PH for penthouse. And again, I'm going to open up that curve input and we'll change our indexing. So we've done 0, 1, 2. So the next member would be 3 and then 4. And I only happen to have 5 members in this list, so 4 would be our last member. I'm going to delete that last one there. We'll leave the curly brackets and I'll select apply. And now that generates the next 2 members, or the next 2 forms for the building. And then I could change the width. So if I wanted those 2 forms to be set back a little bit, I might do a -5, width -5. We'll enter that, and now that begins to step back. So indexing is a way to identify particular members within a list. However, if we were to change the height of the building, which would add additional floors, which means we'd have additional arcs there, those would get left off because we've specifically designated the first 5 arcs and we haven't addressed any additional arcs. So this is where a list function might be useful. So there are a number of different list functions that could be applied to lists to modify the retrieval of the members in the list. So the 2 we're going to use here is list.first, which would return the first members of the list, and we can add a count to that. So we can say the first 3 members or the first 5 members. And the second one we're going to use is list.last, which will return the last members of the list. And again, we can use a count to determine how many of the last members of the list. And then there is a third function which we will use quite often, which is the list.count. And that simply returns an integer that represents the number of members in the list. So for instance, currently the count on my ArcGR list would be 5. But if we add additional floors, then that count will change. So I'm going to go back to that forum GR node. Let's open up the script editor again. I'm just going to delete what I have in there. And we're going to type this in differently. So I'm going to type in that ArcGR. And then I'm going to use what's called the dot operator. So I'm going to type in a period. That's going to give me a list of various functions or properties that I could select from this list. So I want the function first, and I can actually just start copying it, and the list will filter down, and I could select it. And then we need parentheses to put the count. So I'm going to do the first count, the first parentheses. Now, if I could simply do a closed parentheses here and leave that blank, and that would only give me the first member of the list. But we want, for instance, here 3 members of that list. Or perhaps what we actually want is the total count of floors that we have minus 2. If we're intending to have 2 penthouse floors, we could take the entire count of the list. Then even if the number of floors change, we'll have all of the first arcs minus 2 of them. So we're going to use a second function to do that. So again, I'm going to type in ArcGR. Then I'm going to use that count function. So I'm going to do the dot, and then I'll just start typing. And I can select count. So that's going to give me the count, the total number of arcs, and then I'm simply going to say minus 2. And I'll close that parentheses. That's going to give us all of the arcs that are created minus 2 of them, minus the last 2 essentially. So we're going to apply that. Now it's not going to change anything because that's essentially what we have at the moment. So we can see that. And I could do something similar on the form penthouse. So again, I'm going to go back to the curves. I'm going to delete what's in there. And again, I'm going to use the ArcGR. This time, type in the dot, we're going to use that last function. And the count, this time we can simply put in the parentheses as 2. So we're always going to make the last 2 floors the penthouse floors in our massing. And we're going to apply that. So again, we don't see any change because we're simply rewriting what we had put in there with indexing. The difference is I could go to my control panel now, and I could, for instance, change the height of the building. So we'll say take it up to 120 and apply those changes. And we can see now the first 6 floors are the width and the last 2 floors are the penthouse floors. So it's going to maintain that relationship regardless of how many floors we have. So I'm going to go ahead over to my Transactions tab and record those changes. Now we have defined the penthouse floors at 2. Again, anything you create as an input, you could create a slider for. So if you would want that to be a variable, you could control how many floors become the penthouse floors. You could create another slider and call it the number of penthouse floors, and then we would simply work that back into the expressions we created for the curves on the form inputs. And finally, in the next session, we'll go back to our floor plates and look at how to create a watch node so that we can watch the area of each floor plate.